Let's find the derivative using the shortcut rules that we just learned about. So here's a function y equals 14 minus 14x squared. So I'm going to do it three ways. First, this is what's actually happening. That's not the way you end up doing it in practice, but it shows what's really going on. So we say, okay, we're going to take the derivative of this. And that's where the prime notation comes in pretty handy. So the derivative of subtraction is a subtraction of derivatives. So that's using one of those rules. The derivative of a constant is 0. And then you have this subtraction, which is the same as minus 1 times. And then you have the derivative of a constant times a function is the constant times the derivative of the function. So see this, the 14 sort of factored out, and now you have the derivative of the x squared. Then I just took this negative 1 that's actually here, multiplied it in with the 14 and got negative 14. So now I'm here. Now I take the derivative of x squared. The 2 comes down the front, and the exponent decreases by 2 minus 1 is 1. And that's just x the first. 2 times negative 14 is negative 28. And there you have the derivative. What you actually do in practice is you have your function here, and you say, okay, the derivative of 14 is 0. Then this is what you do in your mind. You take this 2, you bring it down in the front and hit it on the 14, which gives you the negative 28. Decrease the exponent by 1, which just gives you the first power, and then that's just negative 28x. Okay, and then always in the background, every time you do one of these problems, you think about back to the limit definition, what really went on. And here's what really went on. So always in the background, you're thinking this. You're shortcutting doing this work. 14 minus the 14, x plus h squared, minus the function over h, the difference quotient. You expand out the x plus h squared. You see that Pascal's triangle occurring there. Then you get down to this step and you see that the negative 14 squared and 14x squared, or negative 14x squared and 14x squared cancel out. Like that. The h divides in, and you see the negative 28x surviving, and the negative 14h, as h goes to 0, goes to 0, so you just get negative 28x. So this is what you actually do. This is why it's happening, and this is always in the background. Always returning back to where this all came from, was from the difference quotient, a rate of change, and the limit as h went to 0.